Hello and welcome to Computer Science 248 Operating System Programming. My name is Dr. Anthony Varghese and you'll be seeing a little bit of me this semester. I hope you've had a chance to look at D2L, excuse me, taken a look at the syllabus and things like that and the first lab. So let's get started. So I want to talk about a few terms in this first lecture, and this is all from the book Unix Unbounded. I've updated a few things, but it's basically exactly what the book has. And like it says here, the first chapter will describe some of the fundamental terms in computer hardware and software and look at different kinds of software. And we look at the importance of the operating system. And this course is pretty much about how we can use the operating system. Okay, so this is going to be a little bit different from what the book has, because what the book has is a little bit old. The book itself is not that old, but some of the terms are on the old side. So I have divided up computers into 4 different things. So the simplest ones, or the smallest ones, would be mobile devices like smartphones, tablets, or embedded devices like GPS units or some MP3 players. Other devices also have a computer and an operating system. Then you have your familiar laptops and desktops. You've all seen those. And then there are servers. Servers are usually a little bit more hefty, that's a little bit more powerful computationally than laptops or desktops. And then supercomputers. Some of you might have used supercomputers. Okay, so we're not going to talk much about supercomputers, but we look at some of the differences of these in between these kinds of devices a little bit more closely. Okay. Notice that all of them will have CPUs. You have to have a CPU to have a computer. Some of them have GPUs, that is graphical processing units. A typical mobile device like a smartphone or a tablet will have half to a gigabyte of main memory. So that's 500 megabytes, about half gigabyte. And then maybe 4 gigabytes of disk space. And when I say disk, could mean flash memory, and it's meant to be used by a single user. So the approximate speed of the CPU is about 500 million instructions per second. These are very simple instructions executed by the central processing unit, or CPU. Excuse me. Desktops and laptops will have between 2 to 8 CPUs. Laptops these days, definitely, they have 2 or more CPUs, and then desktops you can have a little bit more powerful. They might have 8 to 12 to 16 CPUs. They might have 4 gigabytes of main memory, 500 gigabytes of disk space, usually a hard drive, and then they can support multiple interactive users. So multiple users can use the same machine, although typically desktops and laptops are used by a single person. They're not constrained to that. Okay, so what speed are we talking when you have these CPUs? These things will easily run 3 billion instructions per second. A single CPU can run 3 billion, so 8 CPUs could potentially run about 24 billion instructions per second. Servers have even more CPUs, 32 CPUs. Typically, they may not. It's quite common that servers don't have graphical processing units, although some do. Servers can have 32 and more gigabytes of main memory, that's RAM, and easily 10 terabytes of disk storage. They can support hundreds of interactive users and can have many central processing units. So they run 12 billion easily, probably more. Might be about up to 10 times more than that. Okay, so in this first section, you just want to have a rough idea what terms like CPU, GPU mean and where they fit in. So processing is where GPUs and CPUs, well, CPUs mainly for the main part, and RAM, it's also called primary memory, fits in. Without this, you cannot do anything. You absolutely have to have this in any computer. And then depending on what you're talking about, for instance, if you have a server, you don't need a keyboard. It's just sitting out there, and the only input is the network input for a server. But typically for laptop, desktop, you'll have things like a keyboard, mouse, microphone, touchscreen, a scanner, and you have output in the form of a monitor, although not every computer will have one, because if you have a server, you don't need a monitor usually. Also speakers, you can have output going to speakers or printers. You also have typically secondary storage like hard drives or flash memory. So flash memory is now common in desktop machines and laptops, but it started out more useful in things like smartphones because there are no mechanical parts in flash memory, so that you can knock them around and still work. They are a little bit more expensive, as some of you probably have seen. Let's take a look at these basic terms. Central processing unit consists of multiple sections inside it, and you want to read up about this in the book. Things like the arithmetic logic unit, registers, control unit. These are all things that you need for the CPU to work. And different CPUs will have different kinds of these arithmetic logic unit, registers, and control unit. We will see more details about these things in Computer Science 355. I'm not going to do a whole lot in here, but definitely you want to be familiar with some of these terms. The CPU is also called the brain or the heart or the thinking part of the computer. It's the main part where all of the computation gets done. Computers usually have two kinds of memory. It's the RAM that's most important, but when the computer boots up, you need a little bit of RAM, which stores parameters about how to boot up, which disk to use to boot up, things like that. Okay. Finally, I want to end with a few terms about how data is represented. The simplest possible way to represent data is a single bit. A bit can hold either a 0 or a 1. That's the tiniest unit of information that a computer can understand. You put 8 of these bits together and you have what's called a byte, pronounced B-I-T-E, but it's spelled B-Y-T-E. And you want to look up if you're not sure about what a byte means, definitely ask me or look it up online. If you look at how files represent data on any computer, pretty much, what you will see is that there's one standard that most computers use, which is the ASCII standard. It's the American standard. And it says, for example, that the letter A should be represented by a certain group of bits that's 1 byte long. So the letter A, you can represent it with just 1 byte according to the ASCII code. So definitely, if you're not familiar with ASCII, it's something that we go over when we teach programming, and so you should take a look at what ASCII means. Search or ask me later. A word can mean different things depending on the computer that you're using. Most of the time it will be 32 bits or 4 bytes, but it can also mean a group of 16 bits or 2 bytes of data. It can be a word. Some people say that a word, or some computers have the convention that a word is 64 bits or 8 bytes. Sometimes it's called a long word, some people call it a word. Okay, so those are some of the main terms that I'm hoping that you'll be familiar with. If you're not, definitely now's the time to take a quick break and look at what these terms mean. So let's stop here.